Hi everyone, my name is Maria Gevargis and I am going to discuss about the chemical properties of carbonic acid derivatives. Here I am dealing with 5 reactions, that is action with alkaline hypohalites, action with hydrazine, action with malonic ester, action with acid chlorides and acid anhydrides, and action with formaldehyde. Okay, let's move on to the first slide. That is our first reaction, that is action with alkaline hypohalite. Here in this reaction, look at this reaction box. Here we can see that urea is NH2CONH2. Urea react with sodium hypobromide to yield nitrogen gas quantitatively. So this reaction is when urea is treated with an alkaline solution of sodium hypobromide, we get nitrogen gas quantitatively. And this reaction is a basis of hypobromide method, and hypobromide method is used for the estimation of urea in body fluids. Then let's move on to the next reaction, and our next reaction is action of urea with hydrazine. Hydrazine is NH2NH2. Here in the box, we can see the reaction as urea react with hydrazine to yield semi-carbazine. And this is a simple reaction. So let's move on to the next reaction, that is the reaction of urea with malonic ester. First, let's look at this box. In this box, diethyl malonite react with urea to get barbituric acid. Barbituric acid is otherwise known as malonyl urea. So in this reaction, malonic ester condenses with urea to form malonyl urea. And we found the application of barbituric acid in the medicinal industry, like in the preparation of hypnotics like luminals, veronals, etc. Okay, and then this is a reaction with malonic ester. So let's move on to our next slide, that is the action of urea with acid chlorides and acid anhydrides. Here in this reaction, we have urea. Urea react with acetyl chloride to yield acetyl urea. Here, when urea is heated with acid chloride or acid anhydride, what we get is an acyl derivative which is known as urides. So this is our reaction. Then we have our last reaction, that is action with formaldehyde. Urea react with formaldehyde to yield urea formaldehyde resins. So here we can see that urea plus formaldehyde give resin. And this is formed by the polycondensation. Then what is the term? Here polycondensation. Between what? Between urea and formaldehyde. And the condition provided is weakly alkaline condition. So let's look at this box. Here urea react with formaldehyde to form monomethylol urea. Here what we get first is a monomethylol urea. Then it further react with formaldehyde to form dimethyl dimethylol urea. So this is the reaction of urea with formaldehyde resins. Now let's look the three-dimensional structure of urea formaldehyde resin. In the first reaction we get monomethylol urea, and when it further react with formaldehyde we get dimethylol urea. But when it again and again react, what we get is a three-dimensional structure of urea formaldehyde resin. Then what is the three-dimensional structure of urea formaldehyde resin? That is, when this further condense with more urea and formaldehyde, it get increased cross-linked during the polymerization and which yield a three-dimensional structure of resin. Okay, as the last topic, let's discuss the characters of urea formaldehyde resins. So the characteristics involve, the first property is that it is colorless and it has a good tensile strength and it is hard. And it is water resistant as well as oil resistant, and it is used to make colorless or light colored objects. For example, cosmetic containers, stove hardwares, house utensils, etc. And there is a chance of resins with low degree polymerization, and they are water soluble Hence, they are used as an adhesive for plywood and furniture, to treat with paper and textiles to improve their quality. And these are the characteristics of urea formaldehyde resin. Thank you.